Hi guys, today's problem is task B of AtCoder beginner contest 256. So here's the problem. Let's think about baseball. We have n batters and uh, they get hits in one inning. And for each AI is the number of base that he reach. So for example, if AI is 1, the ice batter uh, hit a single. AI is 2, the ice batter hit a double, and so on. So then what we want to do is uh, to calculate the score P they get in the inning. And the constraint is n is at most 100. So let's think about the example. Uh, A is 1, 1, 3, 2, 1 for 1. So we have 7 batters. The first batter hit a single, and we record 1. We write 1, and then the the second batter hit a single. So uh, the first batter is now in the uh, base 2. Then the third batter hit a triple. So these the first batter and the uh, second batter uh, now come back to the home base. So uh, we get the score 2, and the third batter is in the third base. So and so on. So finally, we get uh, the score 6. So that's the answer of in this case. So let's think about the solution. So first idea is is uh, calculate all the sum for each batter. So the previous graph, uh, we end the calculation here, for example. But uh, it's it's a little complicated to use different calculations for each batter. So for the first batter, we need to calculate A1 plus A2 plus A3. But the second batter has to calculate A2 plus A3. The third batter is weird, A3 plus A4. So uh, this calculation has uh, 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 different uh, so we it's very difficult to handle it. So uh, instead of it, uh, for the first batter, for instance, we calculate all the sum of them. So it means we have to calculate A1 plus a2 plus plus a7. Then uh, check the value is greater than or equal to 4 or not. It's the same uh, to compute the a1 plus a2 plus a3. So for the first battle, we have to calculate it, and the second battle, we have to calculate a2 plus plus a7, and the third battle is a3 plus a7. So we have to calculate them. Uh, 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 it is easier to calculate than uh, these fragments. So this is the first idea. So the algorithm to write is this. For each I, which is between 1 and n, compute ai plus 1 plus plus a n, and uh, and if the sum is greater than or equal to 4, then add p to 1. Otherwise, do nothing for p. And finally, print the value of p. So that's all. That's enough to solve b. But here, uh, uh, I want to tell you the time complexity. Uh, if you if you don't care about time complexity, or uh, all you want to do is to answer task B, uh, you can stop watching this video. But uh, I want to tell the about the time complexity because uh, uh, this leads to more difficult problems. So let's think about it. So the first process, so for the first battle, we have to calculate a1 plus a2 plus plus an. So we need to uh, we need to calculate them. So this process consists of n times addition. Then for the second battle, a2 plus a7 an is n minus 1 processes. So and so on. So we go to the for the nth battle. So the the fourth time complexity is uh, expressed as sigma I of I is between I is from 1 to n. So uh, uh, this is at most n squared. So if n is at most 10 to the fifth, then your code will be TLE. Uh, the constraint n at most 10 to the fifth is uh, usual case of AtCoder beginner contest. Uh, the task B for the task B, n is at most 100, so it's okay. But uh, you should be careful about it. So uh, uh, I tell you about the improvement of the algorithm. Uh, that is, do the process the for process in the reverse order and retain the sum you calculate. So let's talk about the algorithm. The first, let sm, which is a variable for the sum, and let sum variable be zero. Then uh, for then uh, first sum uh, add the sum to an, then sm equals an. So check sm uh, greater than or equal 4, which means so this an is for the nth butter. So uh, in this time we check the n butters case, the nth butters case. Then the next adds the variable sum to an minus 1. Then the sum is an minus 1 plus an. So this is for the n minus 1's butter. And check the sum is greater than or equal to 4, which is he will come back to the uh, home base or not. Then the thirdly, add sum to an minus 2. Then the sum is an minus 2 plus n minus 1 plus n. So this is for the n minus 2's butter. So we go on this process and it ends with the nth case. The finally add sum to an, then sum is a1 plus da 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 plus an. So this is for the first butter. So that's all about uh, the algorithm. So as you can see it, we do the process in the reverse order. And then you may think what the time complexity is. So that is for each step, for each 1 to 3 and to n, you need only one addition. So this uh, add sum add sum to an, add sum to n minus 1. So only we do in the ice process is to add sum to a, a n minus I. Sorry, this is not a n but a 1. So the four operations is n in total. So the time compressed is n. Uh, it's very good improvement for the previous case, which is whose time compressed is n squared. So I recommend you to write this code rather than the previous algorithm. So that's all about the task B. Thank you for watching. My AC code is on the description.